Sorry, I keep pausing at the beginning. It's like the beginning of my videos keep getting cut off because there's just this delay, like I mentioned before, between when it says it's starting and when it's actually recording. All right, so some examples. So the first example we're going to look at is perfect substitutes. And again, we're going to kind of keep the simplest perfect substitutes that we can imagine. So we have we're willing to substitute 1 for 1 between the goods. So kind of going to that black pen, blue pen example, or whatever it was, or the black, blue pencil, or whatever it was in the book. And we're going to kind of assume at this point that P1 is less than P2. So this is going to kind of simplify our analysis just a little bit. I mean, it doesn't make much sense to analyze a relationship between income and the amount of good 1 if the price of good 2 was less than the price of good 1, if you remember. All right, so if you remember, what are indifference curves, budget constraint look like for this case? And then over here, this is going to be like the optimal choice between good 1 and good 2. And over here, we're going to draw this relationship between income and the amount of good 1. All right, so if you remember, the indifference curves for this 1-to-1 substitution will have a slope of -1. Right, so all of these are different indifference curves, and they have a slope of -1. And so here I'm just showing various indifference curves. And so what's happening here, maybe I should have done it the other way, kind of conceptually, but what's happening here is that because the price of good 1 is less than the price of good 2, the budget constraints, so these are the budget constraints in the yellow, if that comes out a different color for you, like it does for me. And they're straight lines, it should be a little dot there. They're going to be flatter than these indifference curves. And so basically, because I mean, remember the slope is negative P1 over P2, and so the slope will be, will be flatter because P1 is less than P2, which means the slope is less than 1 in absolute value. And so what's happening here is that the income offer curve is just kind of going along this axis here, right? And if you remember our demand function for when P1 is less than P2 was just, we'd spend our entire budget on good 1, right? We're willing to substitute, like, we're indifferent between Coke and Pepsi. A can of Coke is the same as a can of Pepsi to us. It tastes the same to us, but Coke is good 1, Coke is cheaper than Pepsi, so every time we went to the store, we just buy Coke. So we'd spend our entire budget on Coke rather than buying any Pepsi. So this was our demand for good 1. And now what we're doing is we're thinking about this relationship over here between income and the amount of good 1. Well, if we wanted to draw this out, M equals P1 times X1, just rearranging this demand function here. So again, you can just kind of think of this as, this is on our Y, this is our X variable, if we're thinking about equation of a line. And so this is like our slope. And so what our Engel curve looks like is something that comes out of the origin. If our income was 0, then the amount of good 1 we'd have is 0, assuming positive prices. And so this is what our Engel curve looks like. And notice that has a slope of P1, a positive slope of P1. This is like the slope of the line, right? If we think of M as the Y variable and X1 as the X variable, intercept equals 0, and we have this line out of the origin. So this is what the income offer curve and the Engel curve look like for perfect substitutes. Now let's move on and talk about perfect complements. Move on to perfect complements. And again, we're going to kind of think of the simplest version of perfect complements, where we want to consume in fixed 1-to-1 proportions. So back to that kind of like left shoe, right shoe example, where we want one of each of them, where we want to have the same number of them together, as opposed to like the tea and sugar example that we talked about, where maybe you want 2 teaspoons of sugar per cup of tea. So we're going to stick to the 1-to-1 ratio here. And so if you remember, when we did that, we started to think about, instead of thinking about it as separate goods with their own prices, if we want to consume them in fixed proportion, it's basically one good with the price of the price of good 1 and good 2 added together, right? It was like, we just thought about it being one good where the price is P1 plus P2 to buy that whole good that we want to consume together. And when we did that, we got the following demand function, which again, we could, this is from last chapter, x1, the amount of good 1 equals m, the total budget, divided by P1 plus P2. And again, we could rearrange this and say m equals x1 times P1 plus P2. And this will be useful when we're thinking about graphing out that Engel function. Again, thinking about this is the y variable, this is the x, and this will be the slope. So let's start off with the income offer curve. It's the amount of x2, or amount of good 2 and the amount of good 1. And if you remember what our indifference curves look like, were these right angles. Right, essentially it was like min x1, x2 were the preferences. And so with these right angle indifference curves, like 1, 1, 2, 2, 3, 3, or 0.5, 0.5, whatever. And so what's happening is that we're increasing income. So this is the optimal choice originally. Then we increase income. Let's draw that a little bit better. And the new optimal choice is this much, and so on and so forth. Sorry, I'm smudging my own lines here, but hopefully you get the idea. And so, again, the income offer curve is just connecting all these points, right? And so what's happening here is that we have this nice straight, it should be a straight line, out of the origin through all these points. And this is the income offer curve. Just a line connecting all these optimal choices. I'm just having a hard time drawing a straight line today, and it's hard to draw these indifference curves perfectly, kind of with no paper, I guess, no graphing paper. And so if we wanted to draw the Engel curve, remember that's a relationship between income and the amount of good 1, we can look at this. If income equals 0, the amount of good 1 equals 0, and then it has a slope of P1 plus P2. So again, we have this line that comes out of the origin. So this is the Engel curve. And as income goes up, we have more of these goods. We're going to buy more of good 1. And the slope is going to be P1 plus P2. Again, this is the y variable. If we're thinking about an equation of a line, this is y, this is x, and this is kind of m together. And b equals 0. So that's why it comes out of the origin. All right, so perfect complements, income offer curve, and the Engel curve. Notice the Engel curves have all been like these straight lines so far out of the origin. We're going to see that one more time when we talk about Cobb-Douglas in a second, and we'll kind of talk about why that is, and we'll kind of classify these preferences in some kind of way.